I'm Carol Ann Riddell, and this is Science and You, coming to you from the Space Shuttle Pavilion at the Intrepid Museum. Today, we're exploring outer space, the vast unknown beyond Earth. We begin with a lesson on the what, when, and how of our universe, from the Big Bang Theory to why some stars live fast and die young.
I'm Donna Hanover here at the Scales of the Universe at the Rose Center of the American Museum of Natural History. What's out there beyond the Earth is a subject that captures the imaginations of people across the planet.
Dr. Emily Rice from the Department of Astrophysics at the American Museum of Natural History says that to understand space, you can start with the Big Bang.
So the idea behind the Big Bang Theory is that when the universe started, it was a very hot, dense, and small area, and has ever since then been expanding. The first evidence that we got for the Big Bang Theory was that the more distant galaxies were all moving away from us very, very rapidly, and the more distant a galaxy is, the more rapidly it's moving away. And really, the only way to explain this, or really the best way to explain this, is that the universe is expanding. But there's also other evidence. One of the biggest pieces of evidence is called the cosmic microwave background radiation. As the universe expands and cools, there has to be a transition point where the universe goes from being opaque to transparent. And when that transition happens, you get a lot of free-flowing radiation. In order to have that radiation, we had to have started with a hot, dense universe. And so that goes into the idea that the universe has since been expanding and cooling off.
Dr. Rice says we are actually all made up of star stuff.
The universe started with just hydrogen, helium, and a tiny little bit of lithium, and just the three lightest elements in the periodic table. But we have so much more. You know, we have this whole periodic table of over 100 elements that weren't there at the beginning of the universe. And so what we've pieced together is that these elements are actually forged in stars. As part of the stellar life cycle, you have elements being fused from lighter elements to heavier elements, and then when a particularly massive star explodes as a supernova, you have even heavier elements being made. The calcium in our bones, the potassium in bananas, the iron in our blood had to have come from these stars.
Stars come in different sizes and temperatures.
A massive star, maybe 10 times the mass of the sun or more, is going to live fast and die young, we say. It has a lot of fuel, but it burns through that fuel much more quickly because it's so much hotter. Right. And so that star is going to explode as a supernova.
Now, our sun is a star.
Yes.
Is it anywhere near exploding?
No. There's good news. So our sun is a star. It won't live forever. Its lifetime for that mass of a star is about 10 billion years, and we're about halfway through that life cycle. And so the sun will live on very much like it is now for about 5 billion years.
Dr. Rice says it can be challenging to measure distances in space. Within our galaxy, scientists can measure distance using the parallax effect.
You can kind of test it out if you hold your finger at arm's length and look at it against a background object as you open and close each eye, your finger appears to shift relative to the background. It's not actually moving, but because you're looking at it from a different vantage point, it appears to shift. And so the same thing happens with nearby stars as the Earth orbits the sun. And so we can take these measurements, watch how much the positions move relative to the background stars, and figure out how far away those stars are.
To measure velocity, scientists can use the Doppler effect.
We can measure how quickly an object is moving away from us or towards us. And we do that by taking its spectrum. So we take light from the object, we spread it out as a function of wavelength. They're shifted to the red, to longer wavelengths if an object is moving away from us, or they're shifted to shorter wavelengths, we call it blue shifted, if an object is moving towards us. And based on the amount of this shift, we can measure its relative velocity to us. We also use the Doppler effect to look for planets, because a planet, as it orbits a star, is also going to induce a wobble in that star. And so what we do is we measure the wobble of the star, this regular back and forth motion with the Doppler shift. And that tells us that a planet is orbiting with that same period around that star.
Now, what do you and other astronomers think about the travel we've been able to do, the pictures we've been able to take? For example, the flyby of Pluto and landing the rover on Mars. How valuable are those events?
Oh, these are amazing. The landing of the Curiosity rover on Mars, that was broadcast in Times Square. So many of these things, the entire world is watching when we land on a comet or when we fly by Pluto for the first time. It's just amazing to be able to share this with everybody on Earth.
So we're getting some answers about what lies out there beyond the Earth. but there's much more to explore. I'm Donna Hanover for Science and You.
The most prominent thing in the winter sky, and the thing everybody knows about, is Orion. Orion is a great constellation. First of all, it looks good. Second, it's got a number of bright stars, so it's easy to see. There are a number of open star clusters in and around Orion, and those are fun. Those are stars that travel together, basically. They're gravitationally bound. Many of them were created at the same time, and they move through the galaxy together. We also have the Orion Nebula as part of Orion, and that's one of the few nebulae that are visible in a city sky. This is an area where new stars are being formed all the time. So if you know what's going on there and you look and you see this kind of cloudy, gassy area in the middle of Orion, and you realize new stars and perhaps new planets and maybe new civilizations are being formed there.
If you've ever wondered what it would be like to travel in space, and who hasn't, our next story will give you some fascinating answers. I was lucky enough to interview astronaut Ron Garan about his voyages on the far side of our planet. Astronaut Ron Garan has logged some 71 million miles in orbit, an extraordinary experience most of us can only dream about. Can you describe what weightlessness is like?
It's euphoric. I mean, it's really it's not like floating in a pool. It's just wonderful feeling of freedom, where if with a touch of a finger you can go flying across the room, and if you're working on something on the floor and you don't want to bend over, you just flip upside down and turn the floor into the ceiling, and it's just an amazing experience.
Garan chronicles his space travel in his new book, The Orbital Perspective: Lessons in Seeing the Big Picture from a Journey of 71 Million Miles. He covers everything from the larger sense of purpose he felt upon returning to Earth to the daily logistics of living beyond our planet. And despite his NASA pedigree, Garan patiently answers the questions we all wonder about. I'm so curious, what are the questions that people ask you the most?
The question that I get asked most is, how do you go to the bathroom in space?
Well, what's the answer?
Well, the short answer is anything that we use gravity for here on the Earth, we use air currents on the space station.
In the book you talked about when you were first trying to sleep, you didn't really know what to do with your head.
Yeah.
What was that all about?
So I'd say it took me 3 to 4 weeks to learn how to sleep, which unfortunately on my first mission was only 2 weeks long, so I never really figured it out on my first mission. And yeah, where my head would go as I relaxed, I found uncomfortable.
Right.
So you just had to learn. You know, I think part of it was the muscles in your neck, or need to get used to that.
Yeah.
And eventually they did, and but once I did get used to it, it's a wonderful sleep because you don't have all the pressure points of laying on a mattress. So each of us have crew quarters,
Yeah.
little closet-sized rooms
Yeah.
that we have, and we sleep in sleeping bags. So you are floating inside your sleeping bag, which is floating inside your crew quarters.
Wow. We met with Garan at the Space Shuttle Pavilion of the Intrepid Sea, Air and Space Museum, where he showed us up close the type of capsule he returned to Earth in after his second mission. So just explain to me where you were.
I was in that seat right there. So the right seat. So your knees are in your chest, you're wearing a spacesuit, you got your helmet on. As you're entering through the atmosphere, the G's really build up. You feel like you have an elephant sitting on your chest. You're struggling to, or laboring to breathe. The parachute's open, you get thrown all over the place. This whole time there's fire going by the window as you're hurling on fire through the atmosphere. It's quite exciting.
It's surprising because it's not as big as I would have thought.
No, it's like 3 guys in the trunk of a car.
Now retired as a NASA astronaut, Ron Garan is busy here on Earth as a global humanitarian and social entrepreneur focused on creating a more sustainable planet. As he explains in his book, it's a perspective he gained by seeing our world from a distance.
It really gives you this sense that we're all interconnected. When you see the planet as a whole, there's also the sobering contradiction between the beauty of our planet on one hand and the unfortunate realities of life on our planet on the other hand. Our planet, you realize when you look at our beautiful planet that life on our planet is not always as beautiful as it looks from space. I think the one thing that I'd want people to take away is that we are incredibly powerful. Each and every one of us is incredibly powerful to affect real change in the world.
And as Ron Garan realized when his space capsule returned to Earth, that change starts by redefining what home means for all of us.
So my window now is pointing at the ground when we finally came to rest, and looking out there, and I saw a rock of flower and a blade of grass, and I thought, I'm home. And then immediately, as I had that thought, it dawned on me, wow, I'm home, but I'm in Kazakhstan. And so I think at that moment, it really did redefine what home was. Home was Earth.
One very special set of stars is called Albireo, and it's a double star. The ancients just thought it was one, so they gave it one name. But in fact, when you look through a telescope, you can see that it's two stars. And what's neat about it is that one is blue, very, very hot, and the other is a red giant. And they think they go around each other, but they're not sure. If they do, it's like every 100,000 years.
Dark matter. It's one of the great mysteries of modern physics, possibly all around us and yet undetectable. Andrew Falzone has more on this enigma of the cosmos.
One of the most basic concepts in science is that everything around us is called matter. But what you may not know is that there is another more invisible side to matter, and that's called dark matter.
We don't know what's in it. We don't even know what it is.
Dark matter continues to elude scientists like Dr. Mordecai Mark Macklow. While little is known about this mysterious entity, we do know that there is a lot of it.
The measurements right now suggest that 80% of the mass of the universe is this stuff, not ordinary matter, not all the stuff that makes us up, atoms, electrons, protons. All that is only about 20% of the matter.
As scientists pointed their telescopes to the sky, they came to realize that the hazy little dots that filled their lenses were actually galaxies beyond our own. The more they observed, the more they measured and realized something was missing.
By going out and measuring with telescopes and detectors, essentially the velocities of galaxies, and seeing how fast they move, and then comparing that to the brightness of the light from those galaxies, which shows how massive they appear to be, and showing that there were huge discrepancies.
The discrepancies were in how much mass was being observed in a galaxy versus how much there should be, and since it didn't seem that all of it was there, scientists originally called it missing matter. Though dark matter has never been directly observed, the Hayden Planetarium space show Dark Universe helps its audience visualize dark matter and its effects on the universe.
Scientists find that dark matter, shown here in black, was essential to forming the large-scale structure of today's universe. This computer simulation traces how cosmic structure evolved over time. The bright knots contain thousands of galaxies, drawn together by the vast sheets and tendrils of dark matter.
There are two possibilities. Either there's some unknown stuff, unknown particles perhaps, or there's something we don't understand about gravity. Right now, the smart money is on it's some kind of particle.
Scientists developed theoretical models of these particles and called them WIMPs, which stands for Weakly Interacting Massive Particle. And while these particles have yet to be discovered, there's a chance we might be able to produce them right here on Earth.
If it's a particle, it could be produced in the Large Hadron Collider, and then we would know that such a particle existed, and then we could count up how many of them there could be in the universe, and that could be your dark matter.
The Large Hadron Collider is a massive particle accelerator located just outside of Geneva, Switzerland. 17 miles of underground tunnels allow for the collision of particles at very high speeds. Researchers hope that WIMP-type particles may turn up as an aftermath of those collisions. Also, underground research facilities like Canada's SNOLAB are looking for dark matter. SNOLAB is over a mile below the surface to avoid interference from cosmic radiation. While there's no planned end date for Dark Universe, the sooner you come see it, the better, because much like dark matter, it may soon disappear. I'm Andrew Falzone for Science and You.
Saturn is definitely one of my favorite planets to see. The rings are just beautiful, and in the small telescopes that we use, the rings are very prominent, very clear, and it has a really big wow factor, and it's really a lovely sight to see.
The possibility of life on Mars has always captured our collective imaginations. As Magali Laguerre-Wilkinson explains, it now seems more science than fiction.
For generations, we've all been intrigued by the mysteries of Mars. Recently, NASA scientists discovered something new on the red planet: conclusive proof of liquid water. High-resolution cameras aboard the Mars Reconnaissance Orbiter, circling the planet since 2006, bring us unprecedented views of strange, dark, narrow streaks, which NASA says clearly indicate flowing waters.
Mars is not the dry, arid planet that we thought of in the past.
Billions of years ago, scientists believe, Mars had enough water to fill numerous lakes and rivers. But this latest revelation is something brand new.
There have been no evidence for water until now.
The presence of a watery history of the Martian surface is no secret. The Curiosity rover has been rolling over Mars and probing below ground since landing there in 2012. In October of that year, this tireless explorer found small amounts of water bound within minerals that make up the Martian soil. So far, the exploration has been a study of the planet by spacecraft and unmanned vehicles. There are currently 5 orbiters surveying Mars from above, including the one that detected the water tracks. The Curiosity, along with the rover Opportunity, which landed in 2004, have been drilling desolate landscapes, collecting samples, sniffing the atmosphere, and doing scientific analysis, searching out environments where life may have once thrived. The presence of even a salty brine that flows in warmer Martian weather fuels speculation that life up there is possible. And following the water is a critical element in that search. Tracking the news, along with the rest of us, are scientists like Martin Weiss, principal investigator at the New York Hall of Science in Flushing Meadows, Queens. What makes this so exciting? Why is this unprecedented?
It's unprecedented because it's the first indication we have in the universe that there is liquid water, and 2, the association of liquid water with life. The basic thing we don't know is where this water is coming from. If the water is coming from the atmosphere and it's just coalescing on this, then that changes the picture entirely. If the water is coming from an underground source or spring, then that is far more important and interesting to investigate. So this is not the end of the story. It's the beginning of a very long story that's going to take a long time to work out.
NASA's stated aim is to have a human on Mars by the year 2037. But there's still a lot to do before that chapter of our Martian Chronicle can be written. I'm Magalie Laguerre-Wilkinson for Science and You.
But if there is life beyond Earth, on Mars or elsewhere, what does it look like? Odds are not what most of us would imagine. Mike Gilliam has more.
It's a question that's been on the minds of men forever. Is there life beyond Earth? And recent developments have only fueled the desire for more knowledge. To get some answers, we've come to the Hubble exhibit at the Intrepid.
It's an exciting time for space buffs and scientists who are looking for life out there. The discovery of liquid water on Mars has once again stoked the imagination.
This is huge. Finding this little bit of liquid water is very interesting and a great reason for us to keep looking into Mars and keep sending probes and eventually human astronauts over there.
Stuart McNeil is an educator at the Intrepid Sea, Air, and Space Museum on Manhattan's West Side. He says when we talk about finding life beyond Earth, we may need to narrow our expectations.
What NASA is looking for mostly is going to be microbial life, which is what we expect to find maybe buried deep beneath the surface of Mars or on some other places in our solar system.
Microbial life would be the single-cell organisms we may have eventually evolved from, according to McNeil.
It would mean that life is a process that happens elsewhere. Right now, as far as we know, we're alone. So just the evidence of that occurring on a planet such as Mars or another moon like Enceladus or Europa would give us a lot of hope that this can be occurring on similar planets and moons and places elsewhere in our galaxy or the universe.
And that could point us in the direction we want to travel in to find life.
If we find a place that can support even just microbial life, that means that it could be a stepping stone for us perhaps going there ourselves. For example, the moons Enceladus and Europa, it is widely believed that there is a saltwater ocean underneath their surface. Here on Earth, anywhere we find liquid water, we find life. So if we know that there's liquid water on these moons, it's worth investigating to check out. A place like Mars, it's very similar. In fact, estimates believe that at one point there was a massive ocean in the northern hemisphere of the planet. Now, it's not there anymore, but maybe we can find evidence that there was life there, or even tiny remaining microbial life. Places like Titan, it's a real oddity in that it is a moon with a very thick atmosphere, and it contains elements and chemicals that we recognize. And the life there would be completely different, if there is life there, than anything we've ever seen before. So it's really worth investigating.
Scientists are investigating in a number of different ways.
There's kind of really three scales to it. Now, we've got inside of our solar system, so that's where we're sending probes and rovers to Mars, places like Mars. There's a mission planned to go to the moon Europa, orbit Jupiter and investigate Europa. And these are being done in very small, tentative steps so that we can begin to really understand what we're looking for. Now, the next step above that would be identifying exoplanets that might be able to harbor life. So satellites like the Hubble Space Telescope, the Kepler Observatory, and then future ones. There's one launching in 2017 that'll be called TESS. That one will be a much more advanced version of the Kepler. It's going to be helping us find and identify and catalog these planets and help us figure out more about their atmospheres, if they're within the habitable zone, and eventually, if we get the science up to a really great degree, identify elements in a planet's atmosphere that can only occur if there is life there.
Other methods are aimed at reaching even farther into space,
such as sending messages, coded messages out to star clusters that'll take thousands and thousands and thousands of years to yield anything at all. But that's for that like galactic civilization kind of stuff.
They are also experimenting with magnetic fields and taking terrain photographs.
It's giving us a better idea of really just what's there.
And what about the colonization of another planet or moon?
Other planets are pretty far off, but if we're looking for a place for colonization, probably our first bet should be our moon. It's nearby, we've been there before, and it only takes about 3 days worth of travel, as opposed to the months and months and months that it would take to go to even Mars. That we know a lot about it.
McNeil isn't quite ready to say definitively that there is life beyond Earth.
So where do you see us going over the next 25 or 30 years?
In the next 25 to 30 years, we're going to see a massive amount of brand new satellites, brand new space telescopes. We're going ideally to Mars. We're eventually going to launch the James Webb telescope into orbit around the Earth, actually to the Lagrange point. It's going to be 1 million miles away, getting us an incredible vantage point of the universe around us. We're going to be taking pictures of other stars, hopefully directly observing exoplanets, and observing more about galaxies, nebulae, and learning more about not just where we came from, but where we're going.
So the search for life continues, with the end results just anyone's guess. I'm Mike Gilliam for Science and You.
Yes, the Amateur Astronomers Association of New York is one of the oldest stargazing clubs in the country. We currently have somewhere between 600 and 700 members, I believe. And we've got, of which there are a number of us who have scopes. We do a lot of outreach, such as what we're doing tonight, going to different places around the city and just letting the people look at the heavens.
The Northern Lights are one of nature's most spectacular light shows, rare and special displays that have star watchers across the world gazing upwards. Ari Goldberg tells us what's behind the phenomenon.
In this observatory at the College of Staten Island, Professor Irving Robbins is able to show off the starscape to a city population that might not often get to see it, and to teach his students about wonders in the night sky, like the Aurora Borealis, the Northern Lights.
My first experience with Aurora, and I just lay there for hours watching the sky fluctuate and move around, change colors. I hate to say it was like getting stoned, but on the heavens.
While the mechanisms that produce this light show are quite complex and not even entirely understood yet, in fairly simple terms, the Aurora Borealis is the result of the interplay among three things: energy from the sun, the Earth's magnetic field, and the Earth's atmosphere.
The sun is a boiling cauldron. The outside surface of the sun is a blazing temperature, right? 11,000 degrees Fahrenheit. As you move out, actually it gets hotter. And so what's happening is the sun is boiling away, in a sense, and it's throwing its guts out into space. We call that the solar wind.
This solar wind is the charged particles of ripped apart atoms, hydrogen protons and electrons and alpha particles shot out toward us.
We have a shield that's sitting there, like a shield sitting there like this. As the wind hits, it diverts the particles. All right? What is that shield? It's the magnetism created in the core of the Earth. If you go and Google the core of the Earth, it turns out there's two parts. There's a very, very solid iron core, basically, and then it's so hot down there that there's another section that's all molten. That molten is molten metal. Metal's a very good conductor, and but that means there's a current and they're generating magnetism, but it gets exaggerated because the Earth spins at a pretty rapid rate, and that spin adds more strength to that field, and the result is we get surrounded with a magnetic field.
So we'd play these little metal bars, these little metal magnet bars in school. We'd sprinkle iron shavings on it, and we'd see the lines of the magnetic field. That's sort of what Earth is like.
Overall, yes, it's a nice way to visualize the creation of the field. So now you have this magnetic field. Because charged particles interact with a magnetic field, it gets deflected away. That's the shield effect.
How important is this shield? If we didn't have the shield, is that a problem?
If we did not have a magnetic field, we wouldn't be talking. We'd probably be dead.
This shield protects us from the otherwise devastating particles of the sun. But just like that school magnetic bar, the field isn't a perfect sphere. Some particles are able to get in at the poles, and some get channeled along the field lines as well. And that is why the northern lights, or the southern lights, are centered on the magnetic poles, where the particles get close enough to hit the atoms of our atmosphere.
But they get through and they hit the atmosphere. Now you got fireworks. What's the fireworks? When you now have atoms, right? When atoms get energized, they release light. So what happens is when that stuff hits an atom, atoms get excited. We call that an excited state. The atom's nice and happy, it's contented, it's not bothering anybody. Boom, the energy hits it, electron tries to get away, atom says, no, you're not getting away, pulls it back, all right? In that process, it had higher energy, it loses the energy, it becomes a photon of light.
And all those colors of the northern lights? That all depends on which atoms in our air are being excited by the sun particles. Each atom has its own unique signature.
Oxygen gives us the green colors, sometimes red, depending on circumstances. Nitrogen in the atmosphere will give us some blue, maybe some violets.
It's not common, but we can see the aurora farther south every once in a while, when the sun spews out a massive wave of energy in the form of a solar flare or coronal mass ejection, more than just the constant solar wind.
The velocities of these particles are so insane. Typically, let's say, slow particles, 200 miles a second. That's how fast these things are moving. That's the slow ones. Faster ones are moving 10 times faster. Gets to our shield, you can have auroras down here in New York, and we've had auroras down here in New York, even down to the equator at times.
In fact, as recently as November 2015, high solar activity meant that parts of New York State were able to catch a glimpse. It may not happen often, and we may not even understand all of it when it does. That's no reason not to look up.
In this field of astrophysics or astronomy, when things are far away and you have a little data, everybody's happy. But when you're right on top of something, but we have so much information that we're confused. That makes it fun for those people in this field.
Of course, living this far south, it's very rare we'd get to see the northern lights from here. However, if you get out of the Manhattan lights for a night and come down to the observatory at the College of Staten Island, you'll see there's no shortage of beauty in the night sky, even in New York City. For Science and You, I'm Ari Goldberg.
That's our show for today. Next month, we are talking technology. We'll see you then. I'm Carol Ann Riddell. Thanks for joining us for Science and You.